chemistry peeps? It's Miss Color going over gas law fun. Here is the state objectives, just straight copied and pasted for you. It looks a little confusing, but this is how I've broken it down for you. These are the laws that you have to be concerned with. They are posted on your reference table, so you do not have to memorize them, but you do have to know which one is which, because what if a final exam question says use the combined gas law, but yet you don't know what that one looks like. So just be able to recognize them. Don't worry about Dalton's law. We don't really use that one for what we need. And ideal gas law is going to become more important after this. Okay. All right, and then I've given you some abbreviations, standard conditions, which are important, and then notice under conversions, we're not going to do any other conversions except for temperature. You're going to most of the time be given it in Celsius, and you have to add 273 to get to Kelvin. And so I know some of these we should probably convert the pressure, but I'm not worried about that. I'm just worried about the temperature, okay? This one talks about Avogadro's law, okay? And this one is talking about this. Remember on your stoichiometry map, you had 22.4 liters. That's an important standard temperature and pressure thing. That's how the volume of gas is, a standard temperature and pressure. An ideal gas has no interaction, but they do elastic collision, which means they move out and then they come back, and then they move out and they come back, and then there might be this one going out this way and coming back, and so on and so on. So what is the kinetic molecular theory? Well, these are the main things you should have gotten out of that PowerPoint. Gas particles are in constant motion and exhibit perfectly elastic collisions, just what I was talking about here. It explains Charles and Boyle's laws. And average kinetic energy, which is the energy of motion of a collection of gas particles, is directly proportional to absolute temperature only. So make sure that you study that. Okay, let's get to the problems. Okay, first two problems are just temperature conversions. That's all they are. Okay, they've given you Celsius and you have to go to Kelvin. Okay, so to get Kelvin, you just plus 273 to anything that's Celsius. And so these are the answers you should have gotten for those, okay? All right, number 3 is Boyle's law, and I know that because when I go through the problem, I underline what I know and what I'm looking for, and that's what I did right here. It gave me a volume. It's asking me for the second volume. It gave me a pressure and another pressure. So when I look at my reference tables, that shows me if I'm looking for a formula that's only dealing with volume and pressure, it's this, which is Boyle's law. And so I plug that in, pressure 1 times volume 1 equals pressure 2 times volume 2. Then I have to divide by 88.2 to get volume 2 by itself, so those can cancel. But what you do to one side, you have to do to the other. Okay, so multiply those, divide it by 88.2, and you should get that. Sorry for the leaning writing. It's hard to video and write at the same time. Okay, number 4, I've written out everything I know, and since it's dealing with just volume and temperature, I look at my reference tables and I know that that is Charles' law. Okay, this is the only formula that deals with just volume and temperature. Okay, so volume 1, 8.98 over temperature 1, which I converted to Kelvin, equals volume 2 over temperature 2, which I also converted to Kelvin, so 312.9. Okay, now how am I going to get out of this one? Basically, you have to cross multiply. Okay, so when you cross multiply, let's do this one and I'll show you on the calculator. Okay. All right. So I've got 8.98 cross multiply times 3.312, so times 312.9. Okay, and that equals that lovely number. Okay, Now I'm going to take that number and write it out. 2809.842. That equals 311 times V2 because I cross multiplied. So now I got to get the V2 by itself, so I have to divide both sides by 311.8. Okay, so that means my volume 2, when I take these two numbers and divide, should come out to, let me double check. Yes, should be 6.71. Now, let me know if I mess up on my math, okay? The next one talks about the combined law, okay? And again, underline what you're given, write it out. Volume 1, temperature is in Celsius, so I added 273 to get Kelvin. Here's my pressure 1. It's asking me for volume 2, clearly what volume. And then number 2, standard temperature and pressure. And if you look on your reference table, standard temperature and pressure, standard temperature is 273 Kelvin, okay? So I knew this was the combined gas law because it gave me volume, temperature, and pressure. And that is the only formula that gives me volume, temperature, and pressure. Okay, so there it is. And so we are going to plug it in, okay? So pressure 1 is 84.6 times volume 1, which is 215, over temperature 1, 296.5, equals pressure 2. Oh, my pressure 2, I forgot to tell you. My pressure 2 is at standard, remember it said standard temperature and pressure. And if you look on your reference tables, it tells you that the standard pressure when it's measured in kPAs is 101.3. So make sure that you look on those reference tables, and I'll show you right here. Here is standard pressure, okay? And it is 101.3 when it's measured in kPAs. If it's ATMs, it's 1. If it's mmHg, it's 760, and we normally don't use this one, okay? So that's where that came from. Okay, all right. So pressure 2 is 101.3 times volume 2, which is what we're looking for, over my standard temperature, which is 273. Okay, so now what do we do? Okay, we have to multiply 84.6 times 215, and that gives me that number, 18,189, and we're cross multiplying, right? Cross multiplying, okay? So that number times 273 gives me a large number of 4965597. And that equals this multiplied by this, so 296.5 times 101.3 equals 3003545 times V2. So again, you divide both sides. So we can mark that out, and V2 is going to equal, type that in again just to make sure, dividing, and I should get volume 2 equals 165.32. Okay, so check me if I made a mistake on that one. Okay. You do not need to do 16 and 17, so stay away from those because we don't need Graham's laws. Okay. Number 8 is Boyle's law, and again, write out what you know, write out your formula, start filling it in. The next one is also Boyle's law. Write out what you know, write the formula, fill it in, circle your answer. The next one is combined law. Again, convert your temperatures, write out what you know. Here's your formula, plug it in. Okay. And then the next page. Do not worry about 11 and 12. Come down to 13, and this is Guy-Lussac's law. Okay, so this one's a little bit different. It's just pressure and temperature. Okay, so I can work this one really quick. So pressure 1 is 3.80 over temperature 1, which was converted to Kelvin, equals pressure 2 over temperature 2. Cross multiply 3.80 times 309 gives us 1174.2 equals 298 times pressure 2. Divide by 298 to get rid of that. Divide by 298. And you should get pressure 2 equals 3.94. Okay. The next one is combined law, which is one that we've already worked. So here, you lay out what you know. Here's your formula, plug it in, and then circle your answer. Number 15 is the ideal gas law. So that one's a little bit different. So we're going to talk about that one. At what temperature will 19.4 grams of molecular oxygen, O2, exert a pressure of 1820 mmHg in a 5.12 liter cylinder? Write out what you know. It's asking at what temperature. So that's obviously the question mark. Okay. The pressure that gave us, because I know this is a measurement of pressure. So pressure is that. The volume is always measured in some sort of liters or milliliters. And where did I get this R from? So when you look on your reference tables, you'll see a gas constant R. Depending on what the pressure is measured in, that's how you choose which one of these numbers to use. Since our pressure was measured in mmHgs, what am I using? That's right, mmHgs are there, so I'm using 62.4. Okay, so that's where the R came from. Now, I don't know what N is. N equals number of moles. I know, more stoichiometry. So this is how you figure out your moles. So you have to find out your atomic mass, rather. So your oxygen is 16 on the periodic table. There's 2 of them. Multiply it by 2, that's 32 grams. That's the atomic mass. But what you do is, just like you're setting up with stoichiometry, you start with what you know, with what's been given to you, 19.4 grams. So here's your 19.4 grams of O2, okay? And beside it, you put 1 mole, always, over the atomic mass, always. This is always how you're going to find N, always. 19.4 times 1 is 19.4. Divide that by 32, and you get 0.61 moles. Okay, so my formula is PV equals nRT. Okay, so I'm just going to plug it in straight is. You can rearrange the formula first if you like, but I like to solve it afterwards normally. So pressure is 1820 times the volume, which is 5.12, equals N, which we know is 0.61, times R, which is 62.4, times temperature, which is what we don't know. Okay, so we're going to take our 1820 and multiply by 5.12, and we get 9318.4 equals, and we have to multiply 0.16 times 62.4, which is 9.984, and that's multiplied by T. So we have to divide to get rid of it, and divide this side as well. And your temperature should come out to be, hold on, let me double check this. Okay, 9318.4 divided by 9.984. And that is 933.3. Okay, so if you find a mistake, let me know. Okay, that is what you should get for that one. If I need to rework that, I will. Let me just double check. 0.61 times 62.4. I did make a mistake. Oh my gosh, it does happen. Okay. This 0.61 times 62.4 actually is 38, I believe. 0.61 times 62.4 equals 38.06 instead of this. Okay, so we're going to divide by 38.06. And that's better. 9318.4. Oops, that was my mouse. Divided by 38.06. And that should give us temperature equals 244.83. There we go. That sounds better. And that is in Kelvin. That's the only unit you really need to worry about right now. Okay. The next page, don't do 16. Or 17, or even 18, and don't do 20, okay? And number 19 is the ideal gas law. Again, put out what you know. There's your formula, okay? Let me know if you have any questions.